Hello, welcome to my talk. I am going to talk about life beyond Java 8. We have seen through the last couple of talks in this session a few mentions of things like records and other features from more recent versions of Java. And the goal of this talk is to kind of take a really quick look at all the features which have come in since Java 8. And the reason being that Java 8 is still, Java 8 is still the most used version of Java at the moment. This is the JetBrains developer ecosystem, the results from the JetBrains developer ecosystem questionnaire from this year. And you can see 75% of developers are still using Java 8, 32% are on Java 11, and then a smattering around the others. Now, these percentages don't quite add up because developers can be using more than one version of Java. But the point is that generally speaking, lots of people are still using Java 8, even though it's, what, 6 years old now or more. Similarly, these are some other surveys that have gone out, which show that, again, Java 8 is the most popular version. In fact, if we go back to the JetBrains one, this is an increase on last year. The Java 11 percentage is an increase on last year. So more people are moving to Java 11, which is a good thing. But we still have a lot of people on Java 8. So yes, this one shows Java 8. And then I did a super, not at all scientific poll earlier this year asking my followers what versions they're using either. So we have a chunk of Java 8, a chunk of Java 11. Now, people might think this is a bit of a weird distribution of numbers because the current version of Java is Java 14. So you can see with my questionnaire results, there's quite a large chunk of people on Java 14. Then it seems kind of weird that we have a chunk on 8 and a chunk on 11 and almost nobody on 9, 10, 12, or 13. So I want to talk a little bit, before we go any further, I want to talk a little bit about why this is, because if you're on Java 8, you might not know what's happened in the sort of political sphere, if you like, since Java 8 came out. So let's talk about, what's happened to my screen? Is it showing in a bit of a weird way? Looks like I've got, I don't know if it's me or if it's the screen sharing software, but let's just make sure that this is doing what it's supposed to do. Well, you can read what it says, that's the important thing. So let's talk quickly about releases, updates, licensing, and support, because this is relevant for your decision on whether to move off from Java 8 and which version to choose. So since Java 9, we have had a release of Java every 6 months, which is why even though Java 8 is still kind of the standard, the current version of Java 14, which seems kind of crazy because that's like, 6 versions later. But that's because we're getting new releases every 6 months. Since Java 9, we get a new release of Java every 6 months. But we do have 2 types of releases. We have these 6-monthly releases and long-term support releases, which means that every 3 years, one release is sort of nominated as the long-term support release. Java 8 is a long-term support release because those versions of Java back in the day usually were supported for at least 3 years anyway. Java 11 is the current long-term support release, and presumably Java 17 will be the long-term support release going forward when we get to Java 17. Now, it's important to understand that this is largely the Oracle story. We have generally downloaded our JDK from Oracle, but Oracle are the ones who've updated their licensing and support models since Java 11, and they would like you to pay for the long-term support version. And because by paying for the long-term support version, they can continue to put staff and resources into developing Java. It seems only fair that someone's paying for Java at some point. Generally speaking, the community has adopted this model of long-term support releases versus these short-lived 6-monthly releases. But this long-term support release idea is from Oracle. What it means is that you basically have 2 options going forward. You can use the free Oracle Open JDK build, which the current version is Java 14. And if you're using the free Oracle Open JDK build, you should be prepared to upgrade every 6 months. So now that Java 14 is the most recent version of Java, Java 13 is no longer supported. It won't be updated, it won't get security patches and so forth. So if you were on Java 13, you need to be on Java 14 now. If you are on Java 14, you need ideally to migrate to Java 15 this September. The other alternative, which is probably more suitable for enterprise type environments, people who want a bit more stability, is to use a long-term support version. So in this case, you should be using Java 11, as this is the most recent long-term support release for Java. So if you're using a long-term support version, though, you may have to pay to put it in production. It depends, because there's more than one vendor. So we usually talk about Oracle, because Oracle has been where we get our JDK from. But of course, there are loads of vendors. This is just like the top few who popped into my mind. But there's a lot of different vendors for a lot of different use cases. They have different support models. They have different licensing models, different cost models, or lack of cost. I would take a look at Adopt OpenJDK. This is a community-led initiative for building JDK. So you can get a free version of OpenJDK from Adopt OpenJDK. This has recently, they've recently announced this is joining the Eclipse Foundation, so it's now part of a foundation for open source, which is a good thing. And its new name will be Eclipse Adoptium, which sounds like something which is going to go into space. So yes, take a look at Adopt OpenJDK if you want a free and community-built JDK, but there are a lot of different options. Now, I don't want to go into this in too many details, because really what we want to do is we want to take a look at the meat of the new features in Java, I think. So that does lead to the question, given all this complication of which version do I choose? Also, Java 8 was kind of nice. I liked it. It had the Streams API, like Tagir was showing, and the Streams API is extremely powerful, and we can use Lambdas, and I'm kind of happy with Java 8. So I don't really see why I should move on. So let's take a look at the new language features to begin with, the new language features available if you're using Java 11, which, if you remember, of course, is the current long-term support release. First, let's look at JShell. Let me get my... okay. Get the right screen up. Right, so JShell, I will use this in Java 11, because I said I was going to use Java 11. Now, JShell is the REPL for Java, and it's a self-contained file. So it doesn't matter which version of Java you're using in production with an application. You can run a copy of JShell completely independent of that. So you can be running whichever version you want. I'm going to run the Java 11 version, because I said we were looking at Java 11. But you could run the Java 15 version, for example, and use it to play with some new features in Java 15, which is coming in September. So JShell, what is a REPL? Some of you may have used REPLs in other languages with other types of tools. In the Java world, we generally have not been used to using a REPL, because we have to build a class with public state void main and all of this ceremony and boilerplate, whereas a REPL allows us to prototype stuff really quickly. For example, I'm going to use tab completion, because I'm used to using an IDE and I want to get tab completion. So I can do system.out.println. I get tab completion and code suggestions as if I was in an IDE. It's a great idea. So then I can print that out there. Note something. I do not need to put a semicolon on the end here. The most exciting thing about one of the features that's come in Java 11. I don't need a semicolon to write that entire line of text. Okay, that's great. You still need semicolons in normal Java. You just don't need them necessarily in JShell. So I can do simple things like this. I can do things like I can declare an int of some value. Oh, what have I done? Of course, I need to give it a name. Some value. And I can, of course, use new features of Java, some of which we will look at later. Like I can use that as a var, not a val, honestly. Anyone would think I haven't been doing any coding all week. There's not a lot of value in using var instead of using int, because it's the same number of characters, but we'll look at var a little bit later on. I can also declare like an anonymous one here, so it will just assign it to $4. I can declare methods, so I can say void print something. And I can say system.out.println something. And then I can call that. And so it's kind of cool. I can kind of gradually build up a more complex set of variables and methods, and I can kind of create, I can experiment with stuff. I use this to experiment with the new convenience factory methods for collections. which we will look at later as well. But it allowed me to kind of play with the new functionality, see what was printed out, see what I can change, see what I can't change, and how does it feel to kind of work with. So it's quite a good way. I would have traditionally used unit tests for all of those sorts of things. I still really love unit tests, but if you're just literally just kind of got to poke the system and see what happens, JShell is quite a good way of doing that. You can also export these as like scripts, and you can import them and rerun them later. So it's quite a powerful and interesting tool. So let's see, and it's got commands as well. So for example, I can print out all the variables and all the methods that I have here. And I think there's a help in here, so it'll tell you all the stuff that you can do. So JShell is really interesting, and I think the reason I mention it first is because you can use it as a tool to play with some of the new features if you want to. Next up, var. We already saw var a little bit. I just kind of showed it. So let's go into intelliJ IDEA, because we are at a JetBrains event, and I am the intelliJ IDEA developer advocate, so I should probably do something around intelliJ IDEA. So var came in Java 10, which means it's available in Java 11. One of the things that's really important to understand, there's two important things to understand for var. One, don't use it everywhere. It's meant to be helpful. It's not meant to be mandatory. And two, it is not about introducing dynamic typing to the language. It is about removing the need to repeat boilerplate. The typing is still available. So let's take a look at this. This is a set of style guidelines for how to use var. It's guidelines. It's not mandating the best way to use it, but it is a good idea to have a quick look at this, to sort of have a look at some of the best practices, if you like, on how to use var. I've covered some of them in this code example. The code is available on GitHub, and I will share a link to everything at the end of the presentation as well. So let's take a quick look at var. Obviously, we can get intelliJ IDEA to convert things for us automatically. So here we can use that as var. I would argue that naming something like this with a var is not super helpful, because it's got a rubbish name anyway. So then I take away the type information, and I can't necessarily see what it is. However, if you are using intelliJ IDEA, it will say, by the way, this is a list of people, which is quite helpful. It's just kind of annotated on top of the lines of code. Where it is really helpful is if you do have this kind of repetition of type information here. This is kind of, you don't really need to say this on both sides of the equal sign, because, you know, if it's on one side of the equal sign, you don't necessarily need to say it on both. So I can replace that with var. That seems like a really useful place to have it, because, you know, it's an output stream. I declare it as a byte array output stream. That's quite helpful. One of the other things to consider, as I said, is var doesn't remove the type information. The type information has to be there somewhere on the other side of the list, ideally. So here's a safe list. We have a list of 1, which will return a list of strings. So if we turn that into a var, it's still going to be a list of strings. Now, I can't do that with this one, because this just says list of. So the compiler has no idea what type this is, because it doesn't have any type information in here. Here it does. I tell it it's going to be a list of strings. But if I change that to var, which I think IntelliJ won't let me do, because it's not a safe thing to do. If I change that to var, I actually get a different type. This is now a list of objects, not a list of strings, because there's nowhere to get the information about it being a list of strings from, which is why IntelliJ says, no, I don't want to do that for you. For this one, no, let's not do that. For this one, the type information is here on the left-hand side and not on the right-hand side. If you get IntelliJ IDEA to replace that with a var, it will put the string over here, so that at least I get that type information somewhere. So it will do the right thing. So this is var. It's just 3 characters. It's nice and short. The idea of var is to reduce the boilerplate in your code. The idea is not to just apply it everywhere. So use it where it makes sense. Use it where it's going to aid readability. Don't use it where it's going to add confusion as to what is this type, what is it doing, what am I supposed to do with it. So it's just another additional tool for you to apply to your code if you've got something which is not very readable. One example is here. This is genuinely an iterator I discovered somewhere. So I have this kind of type information with nested generics. I actually don't care about that. It's just not really important to me. I have an iterator, and that's really all that matters to me. And the same here, my entry, I don't really need that either, because I'm not doing much with it. So again, this is a really good place to use var, where you've got loads of different type information. Right, I don't want to spend too long on var because it's just 3 characters after all. What else do we have? We have, everything is a surprise to me when I do this presentation. Convenience factory methods for collections. Oh, by the way, I will talk quite fast because I gave this presentation last week or the week before. I had 75 minutes and I didn't finish it in time. And this time I have 40 minutes. So I'm fully expecting Nala to jump in at some point and say, that's it, you've got no more time, you are done. So I'm going to try and get through it quite quickly. There's a lot of information to cover here. Convenience factory methods for collections. Let's have a look for, I called it Java 9. Here we go. If you want to create an unmodifiable list, a list of values that you can't add to, remove from, or edit, then really the correct way of doing it is do something like arrays.asList and then wrap it in an unmodifiable list. Often we actually forget to do that, or we choose not to do that because that's a load of work, and we often use just that, which is actually not the right way to do stuff, because you can alter the values in this list. We tend not to, but we can. Now, in Java 11, you can say, you can press the wrong command, you can say, replace this with list.of. I think we saw this earlier in Tagir's talk, actually. So you just say list.of, and you get an unmodifiable list of the values that you want. That's fine, that's great. In the list case, it's kind of useful, particularly around having an unmodifiable list. It's much more helpful in the case of something like set, because with set, you have to say, you have to create a list and then wrap it in a hash set and then wrap it in an unmodifiable set, which probably explains why no one in the Java world ever really uses sets, because it's quite difficult to work with. But now you can replace it with a set of, and that's way more readable. I think this is very helpful for things like creating test data, but we'll probably find places where we use this in production code as well. We can do something similar with maps. Initializing maps is a little bit ugly. We have to have some sort of static block somewhere adding values to it, or some sort of method which adds values to it, and then wrap it inside an unmodifiable map. In Java 11, we can replace this with a map.of entries. So then I say of entries, and then I create these individual entries for each of the entries in the map. If I static import this, static import, it makes it a little bit smaller, and that's kind of fine. It's a bit more readable. I would format that on multiple lines. If you have fewer than 10 items, then there's a more convenient way of doing this. So you can say map.of, and then you just have key value, key value, key value, and that can be a bit more readable. I still think something like Groovy has a more readable way of creating maps, but this is still significantly more readable and more less verbose than what we were doing before for maps. So I'm a big fan of these factory methods for collections. I've started using them a lot since I upgraded from Java 8. Added to that, you can now, we talked about creating unmodifiable collections. Now the Streams API allows you to collect to an unmodifiable list, unmodifiable set, and so forth. So this is a really nice addition for using the Streams API, because often what you want is to wrap it in an unmodifiable something. If I create a set of results and return that set of results, I don't necessarily want someone messing with that set of results. So this is a really nice, small addition, but a nice addition to the language. We have new methods on the Stream API. We looked at this a little bit in the last presentation. The Stream API is kind of fairly static, but in Java 11, we do have take while, which allows us to take all the values in the stream until some condition is met, and then we stop the stream. There's a sort of a sister method called drop while, which will ignore all the values in the stream until some condition is met. And in fact, you can actually use both of them to sort of bookend your stream if you want stuff in the middle. So this is a really helpful thing, particularly for working with infinite streams. You kind of want some sort of condition to say, I don't care about these at the beginning, I don't care about these at the end. We also have predicate.not. This sounds kind of silly that we have a new static method which is 3 characters long plus the brackets when we could just use an exclamation mark. Let me show you where some people are finding this useful, if I can remember where I put it. Oops. It's getting hot in here. My poor laptop is saying, it's too hot, I can't cope. What was this? Java 11. Here we go, predicate.not. So in the strings API, you can say, I want to filter for everything where the string is not empty, for example, and that's absolutely fine and completely readable and totally all right. But some people would prefer to use a method reference, and you can't use a method reference when you're using the not here. So in Java 11, what you can do instead is you can say, I want to do predicate.not, and then I can use a method reference here. It's just a matter of personal preference. It's arguably, it's more characters maybe. It's like one more character at the end of the day once you've removed the lambda. It's really about readability and what works for you. So it's just nice to have that there if that's the sort of thing that interests you. New methods on optional. Optional was a nice addition to Java 8. Let's find optional. New methods on optional. Optional was nice in Java 8. I really like the idea of having a type which explicitly says you might get a return value from this method or you might not. So if you want to find a user and it returns you an optional, then you're like, okay, well, I have to check whether something's here or not. It's much more explicit than returning a null, because a null could be, I didn't find the user, or it could be, I threw an error, but I didn't want to tell you, so I gave you a null, or it could be like something else went wrong, or you don't really know what null represents. It has no meaning, no context. Whereas optional has real meaning. Optional means I am here or I am not. So that's great. But it did have some limitations. So you could use it with, let's see, you can use it with, did I put it in here? Probably not. The idea is you say you want to wrap it in a present. Let's flip that around actually. Let's get intelliJ to flip that. So this is kind of the classic way of using inside Java 8. And if you want to, will this suggest it for me? No. Okay. Or you use if present and use it in a more functional style. And that was really only limited to the if present case. Whereas Java 11 has a bunch more methods on optional which make it a lot easier to work with. One is, instead of having to say not is present, which humans are not very good at parsing nots, you can say is empty instead. So again, this is about readability thing. It does exactly the same thing as the other one, but it's just potentially a bit more readable than trying to add a not in your brain and flip things around. So that's quite nice. Another thing, you can say or else throw. So you can say, I want to return this optional value, the thing wrapped inside this optional value, or I want to throw this exception, or else throw. And again, you can see this is a Lambda expression, so this is like lazily evaluated. So this might be a more functional way of kind of expressing what you want, and it might be more efficient. One of my favorite features is if present or else. So when I was trying to migrate a set of code that uses nulls to mean I don't really know if it's there or not, I was trying to migrate it to use optional. I found myself in a lot of cases where I say if present do this, but I still need the if, I still need the else bit as well. So then I couldn't use a functional style of working in Java 8. I had to have an if-else statement, which looked kind of clumsy. Whereas with Java 11, I can give it 2 lambdas. So if it's present, then do something with it. Otherwise, do something else that doesn't need that thing. So it just kind of reduces a lot of the boilerplate, allows you to use Lambda expressions the way that they were intended to be used. And there's another function, which is another method, which is or. So this is different to the other methods because the or returns, let me show you. The or returns another optional. So this is where you actually want to work on the optionals, not on the value that it wraps. So I might want to say, I want this customer to be either the customer that you get or some other optional, which may or may not be available. And of course, you can chain these. You can continue to chain these for as long as you want. This, again, allows you to be a bit more powerful with the way that you use optional. And you can use optional.stream to allow you to use optional inside stream operations. So it's a bit more, again, there's far less like clumsiness around managing optional. So if you're using optional in your code base in Java 8, you might find that moving to Java 11 gives you much more power and flexibility in the way that you're using optional. Java 11 has a built-in HTTP client. This is helpful for writing tests. It's helpful for if you're using like microservices. It means you don't need an external library. A lot of people I know who are looking at Java 11 were very interested in the idea of using a built-in client rather than having to use an external library. Java 11 has multi-release jar files. I wrote about this back in 2017. This is kind of like a really rough way of producing multi-release jar files inside intelliJ IDEA because I was experimenting with the feature. It's not necessarily applicable to us as enterprise developers who are working on an application inside a large organization. But if we're library developers creating a jar file that we want to distribute to other people, this can be very helpful. What it means is that when I distribute my jar file, if I have built it using Java 11, for example, and I distribute it to you and you're using Java 8, the jar file will use Java 8 if you're using Java 8 and the features in Java 8. But if you're using Java 11, it will use the features available to it in Java 11. It's important to notice this is not about API level things. So it's not about you're using Java 11, so you can use a Java 11 style API with my library. No, it's more about under the covers. Under the covers, I, as the library developer, can use the Java 11 features on your machine to do things faster, better, quicker, whatever. So it's very helpful for library developers. As an application developer, this is largely invisible to you, but it will actually benefit you, especially if you have moved to a more recent version of Java. Jigsaw was the sort of big ticket item in Java 9, which was supposed to call the Java module system, actually. And probably, again, if you're working on an enterprise level application, you're probably not that interested in using the Java module system to break your monolith or even, you know, microservice into modules. But it does benefit us in a number of different ways. Again, library developers can use it to break their jars, their libraries into a number of different modules. It benefits us that Java has been modularized because actually we can do things like we can use JLink to package our application with just the bits of Java that we care about. So if we're only using like 4 or 5 modules from the JDK, we can package up our application, the 4 or 5 modules from the JDK, and put all of that into one thing and deploy that to the cloud. So our deployables might be a lot smaller, they might be cheaper, it might be quicker, all of these different things. So the Java module system might not excite you in terms of modularizing your application, but it has led to a number of improvements and benefits in terms of the Java, the platform, having been modularized. Right, so those are the benefits, the sort of features available to us in Java 11. Let's take a quick look at Java 14. Again, just to remind you, Java 14 is the latest version of Java. It came out in March. So if you are following the kind of 6-monthly release cadence, you should be using Java 14 and then migrating to Java 15 in very short order, depending on when you're watching this video, actually. So yeah, so for now, it's the latest version of Java right now. Java 14 has switch expressions as a standard feature. Let's look at switch expressions. Oh yes, because that's what switch expressions meant again. We're all familiar with the classic switch statement. Probably, I would hope, not many people are using it because it's not very object oriented. It's a little bit like code from the 1990s. Switch expressions allow us to write the same thing in a much more modern way. It's just much prettier. It does the same thing, actually, potentially has the potential to do more than the original thing. And a switch expression returns a value. So whereas with a switch statement, we have to set this value in here, and we get this nasty kind of code. A switch expression, we can return something from the switch expression, which also means that actually we can just inline that straight away and do that. So our code is smaller, prettier, possibly more readable. We have flexibility too. We can do things like, I'm having real trouble with my keyboard today, but it's not my keyboard, it's entirely me. We can, yes, I want to put that in a code block. So then I could say something like, do some complex stuff here, etc. And then we use the yield keyword to return the value from the switch expression. So, so this is nice. I think switch expressions are a really nice addition to the language. They are a standard feature now in Java 14, so you can use them in production code. It's absolutely ready to go. We have text blocks as a preview feature in Java 14. So now is a nice time to talk about preview features. the 6 monthly release cadence has kind of, plus modularization, I guess, has allowed us this idea of having preview features. So this means that the language developers can put in a feature that they think is pretty much finished, they've thought it through properly, and they kind of want the syntax to be nice. They put it out into the wild for us as developers to use, but they put it out there as a preview feature and say, use this and let us know how you get on with it. And if it's not, if there's some edge cases we haven't considered, or if the syntax is kind of difficult to use, let us know so we can update it in the next version of Java. So text blocks was a preview feature in Java 13. It is also, it has been changed slightly and is a preview feature in Java 14. It will be available as a standard feature in Java 15. So actually you can use text blocks as a preview feature in 14 and it won't change by the time Java 15 comes around. So having said that, speaking of preview features, so this yield keyword, this is one of the things that was changed between the different preview features of switch expressions. This was originally break, I think, and is now yield. So we play with the syntax as a preview feature, and then when the syntax has kind of stabilized, it will be released as a standard feature. Now, preview features are not enabled by default because we shouldn't use them in production. So in intelliJ IDEA, for example, let's no, put the wrong thing. We want to, if we want to play with the preview features, then we want to select the preview. So we're talking about 14 here. So we want to select the preview version of the project language level in order to unlock it. And we need to do the same thing in Maven. So let's have a look at my Maven file. So here we have, we need to say enable preview. So the preview features are not available to you by default. The preview features are only available if you turn them on. So having said all that, let's look at text blocks. Text blocks are a way of us to not have to have all this nasty escaping inside blocks of text. So often we'll find ourselves having different languages or different big blocks of code inside our code. With text blocks, let's convert this to a text block. We just have to say, start it with 3 double quotes, and then we put the code in here and then close it off with 3 double quotes. And look, we don't have to escape anything. So it's much more readable. In fact, one of the nice tricks that a lot of people don't realize in intelliJ IDEA is you can inject a language. So here we can do, let's inject JavaScript, and then I get syntax highlighting and code completion inside this string for JavaScript. This applies even inside normal strings. This is not just a text blocks feature. This is a thing. So text blocks are useful for things like embedded HTML. It's the white space here is significant, so you can do formatting inside the text block. It makes it much more readable and easier to see. I can put my SQL in there. Again, one of the things I would do is I would inject SQL in here so that I can see my syntax highlighting for SQL. And I think it's really useful for JSON because JSON has like all of this escaping, and it's all kind of like, I don't know if this is a valid JSON string, so I would put that inside a text block like that. So it's much easier to read. This, as I said, this is a preview feature in Java 14. It will be a standard feature in Java 15 in September. Pattern matching for instance of, another preview feature. Let's take a look at this. One of the things which feels a little bit old-fashioned about Java is we do an instance of, and then even though we know inside this block that this person is definitely an employee, because we've just said, is it an employee, we still have to cast it to an employee, which is, it's a little bit icky. So with Java 14, we can give it a pattern variable. So up here, we just say instance of employee and assign it to a variable called employee, and then we can use an employee inside that block as if it were an employee. So that's really nice. It's kind of, it feels like a fairly small feature, but it's the start of a bigger trend inside Java in terms of pattern matching, which is a nice, powerful language feature, which will allow us, I think, to write more readable code and to kind of, as a human being, parse the code more easily. So I expect more from pattern matching going forward. So that is a preview feature in Java 14. Records is my favorite preview feature in Java 14. It is, it's a really silly thing. And if you're using Kotlin, you'll have seen the functionality with Kotlin data classes. But it's just a really nice, easy thing. So we create a new Java class. I'm going to call it a user. I'm going to make it a record. You see here, it's flagged as a preview feature. And then all I have to do, let's add that to Git, is say I want an int, which is an ID, and a string, which is a name. And then that's my whole object. I know people are using Lombok and stuff to do this kind of thing, but now this is part of the language. So you can literally say, I want an ID and a name, and I will automatically get getters, a canonical constructor, which takes all of those values, and hash code equals and toString default ones under the covers. So I don't need to create all of those things at all. They're just there. So yes, that's really helpful. I can, if I want to, I can override these things. So I can have like a canonical constructor, and then I say, look, I don't know, do some validation here. So I can override those things if I want to. I can also use what's called a compact constructor. Can I do that? Generate, let's get rid of this and do a compact constructor. I can generate a compact constructor, and then this way I don't have to say this, because I already get those. So I can say, I can still access those things. They're right there. So I can say, I don't know, validate ID. Okay, so I don't have a validate method, but yes, so records are really nice. They're a really nice way to I think, particularly for things like data transfer objects, or like small data objects like data classes, to encapsulate this data in a sort of meaningful way without having to generate all this code. And one interesting thing about records, let's go to my record test, is our getters. So I have a record here. Have I got getters? Well, let's pretend I've got a getter. Our getters don't start with the word get. They're not called getters anymore, they're called accessors. So that's kind of, I think that's quite controversial, but I think it's great. I mean, why should everything begin with get just because of the Java Beans specification from 1,000 years ago? So this is kind of nice. So records is my favorite new feature from Java 14. Records, right. So that's Java 14. Those are all the features you can expect to see in Java 14. A bunch of them are preview features, so you won't be using those syntax level features right away, but you can start playing with them. I do want to look quickly at Java 15, partly because Java 15 is only a couple of months away and is fairly, it's already in a fairly stable state. And partly as well because I spent this week documenting the Java 15 features in intelliJ IDEA for the 2020.2 screencast video, which went live this week. So since I already worked on the Java 15 features, I thought I might as well show what they are. Firstly, text blocks, which I just showed you, are now a standard feature in Java 15, so you can use them in production code, no problem whatsoever. The pattern matching for instance of is going into its second preview, but as far as I could tell, nothing's changed for that. So the functionality is exactly the same as it was before. Records gets a bunch of new functionality in Java 15. So things like non-private constructors, annotations, and local types. Let me show you these quickly because I liked all of them. So if previously your constructor had to be public, now if your record is not public, then your constructor does not have to be public, which makes a lot of sense. So I don't have to have a public constructor. Another thing is I can create my getter, records now support annotations. So I can have annotations wherever annotations are valid on a class. So that's quite nice. Another thing which just blew me away is local types. So I can use in Java 15, remember, not Java 14, in Java 15, and again, a preview feature, I can declare a local record inside a method. And this allows me to create like a temporary container for some stuff. So here, what I've got is basically a pair of a person and the list of the orders that person is associated with. Now, I wouldn't go overboard with this because sometimes if you're having to group together data like this, maybe there's something missing in your domain object. But sometimes literally what you want to do is just like iterate over a bunch of stuff, do some things, and then produce a result. So sometimes you just need a temporary container for that sort of thing. And I think records is a really interesting way to do that. Similarly, given that we've got local records, we can now also have local enumerations, which I kind of figured maybe we could use that for like tagging stuff inside the method, maybe associating it inside a map. I played with it for a bit, but I didn't have a real use case, but it seemed interesting. And you can also use local interfaces, which I couldn't think of a use case for, but I'm sure, like, when I see someone else's code, I'll be like, oh, that looks really cool. So now you can have local interfaces, local enums, and local records inside your methods. What else? Sealed types. Again, something that you might be familiar with from other languages. I can have I can declare a sealed class. So my sealed class permits only subclass being subclassed by the specific list of classes. So you can have like more than one here. I can say another class. I think it's a, yeah, it must be a comment. So yes, so then I can say I have a sealed class. It can only be overridden by these things. And if I go into this class, this has to be sealed or final as well. So it allows us to kind of set up sort of contain hierarchies for our classes. It could be, I think again, it could be really good for things like library developers who want to be able to create a hierarchy, but not have their users inheriting from the sealed classes, the classes they want to be sealed up. So sealed classes is interesting. Again, that will be, that's a preview feature. Hidden classes are also going to be available in JDK 15. I have not actually played with that, and it's not a preview feature, but it seems, again, something which will be very helpful for the language developers and maybe library developers. And ZGC, which is another garbage collector, is production ready in Java 15. So we'll talk a little bit more about garbage collectors in a second. Oh, look, I've got 1 minute to get through the rest of my presentation. What could possibly go wrong? You can see Mala looking all nervous. You've got loads of questions, Trisha, get off with it. Okay, if you want to know everything to do with JDK 15, you go to OpenJDK. Let's whiz through really quickly some of the other things which are interesting or not, I mean, whatever. In the future, there are a bunch of projects which lump together the functionality which is being worked on for Java. In the past, perhaps with our big releases, we might have expected to see like the whole project be delivered with one of these big releases. But with the 6 monthly releases, we can kind of see them incrementally dripped out. In particular, Project Amber, which is all about trying to make code more readable. A lot of the features that we looked at here, I think things like var and so forth, they are small features which are part of Project Amber. So we can kind of expect to see an incremental set of things released under Project Amber, for example. Valhalla, Loom. Loom is interesting. Loom is about new concurrency in Java. I don't think there were any proposed dates or times on any of these things, but yeah, Loom, Valhalla, by the way, is basically about performance. More garbage collection improvements, and there's a proposed new project which was around improving the startup time for Java. Now, you need to sell these things to the business. The business doesn't care about your ability to use var instead of having to type string all the way out. Like, they really don't care about that. So let's just do a quick high-level view of why you might want to use a more modern version of Java instead of Java 8. The most compelling reason, I think, is performance. You can run your application on a new version of Java, and generally speaking, you will see it perform better. By perform better, I mean lower latency or potentially smaller memory use. So let's move on to use of memory. There are features like compact strings and a bunch of other features which happen under the covers, which make Java more efficient to use if you're using a more recent version of Java. There were other features around performance, by the way, around things like Docker. So modern versions of Java play much better with Docker. So since a lot of people are kind of using Docker, this seems like it's kind of interesting to know. And so use of memory, generally because of compact strings, etc., you might find it uses less memory. Again, interesting from a cost point of view, because if you're running in the cloud, the amount of CPU and memory you use is costing you money. On the topic of memory, Java 11 had a bunch of garbage collection changes. So now G1 is the default GC instead of, oh my goodness, I can never remember, CMS. So we've got a new garbage collector as the default GC and a bunch of features for G1 to make it more performant. And there were 2 experimental garbage collectors which you might want to play with to see if that actually helps in your use case. Now in Java 14, we have another experimental garbage collector and a bunch of changes for G1 and for ZGC. I'm guessing the Americans would say ZGC, but I'm not American, so I'm going to say ZGC, and I'm going to carry on saying ZGC. Another reason to move forward to a more recent version of Java is cost. I kind of mentioned this from the point of view already in terms of like cloud with smaller deployables, smaller memory footprint, perhaps more efficient use of CPU, more, performance would generally, if you've got higher performing code, it will probably cost you less, especially if you're running in the cloud. But what I really wanted to highlight here is there's also a kind of like opportunity cost, if you like. It's going to become more difficult to retain and hire developers if you keep being stuck on Java 8, because it does have some interesting new features. And people are going to want to, Java developers, of which there are many, are going to want to start to use the more recent versions of Java. So the longer you wait to move to 11 or 14 or 15, that you are potentially losing opportunities to hire some of the, I don't want to say best Java developers, but you are decreasing the pool of developers you could be hiring from. Right. I don't really have a lot of time to talk about this, but I want to quickly mention about migrating. You could try running your application on an updated JDK. It might actually just work. You might not need to do anything. I have seen that happen in some cases. If you have compiler warnings, deprecation warnings, any sort of warning when you're compiling the code, get rid of whatever's causing that problem, because they are there for a reason. And things like deprecation, for example, is being taken much more seriously. So stuff is going away and will need replacing. Do update your dependencies. You will need to update your dependencies for using some more recent versions of Java anyway, and it's a very good idea to do this for security reasons anyhow. You may need to add new ones. Java 11 in particular removed a bunch of stuff from the JDK. So JAXB is not available as part of the JDK. That's now an external dependency. JavaFX is an external dependency. So you might need to update your dependencies to add dependencies on these external libraries. And you can do that now. You can do that on Java 8. You don't have to wait to migrate before you do that. You do need to update your build tool. The most recent versions of Maven and Gradle are required to run Java 14 specifically. So, and again, this is just a good thing to do anyhow. Then you can try compiling against your updated JDK and then start using the shiny new features. Don't do this step first. You need to try all the other stuff first. If you do this straight away, you probably will have problems. Just do those steps of migrating. I did write an article about upgrading from Java 8. It says to 12 because I wrote it last year, but a lot of the steps are still applicable for now anyway, for Java 14 or 15. Right, so in summary, modern Java can help you. It's got better syntax, it's better performance, it might be easier to maintain. There are two upgrade options. You can upgrade to Java 11, which is the long-term support release, or upgrade to Java 14 and potentially upgrade every 6 months. It is a good idea to look at upgrading now and to reduce the future pain. As in, I don't know what's going to happen if people try and upgrade from Java 8 to Java 17. It just feels like that would be a big step. So I think upgrading to 11 now and then potentially testing against the 6 monthly releases in CI, I think that makes sense to me. Right, so all of the resources for this talk are available at this link. That includes all the slides. It includes links to loads more additional information. I wrote a bunch of blog posts about some of the functionality. Mala wrote loads of those blog posts I referred to. Like, she's always covering all the great stuff about what's new in Java 12, 13, 14. And I'm assuming you're going to do a what's new in 15 blog post on the intelliJ IDEA blog. So all of those are linked to from this link here.
Thank you, Trisha. It was an amazing presentation, and I see a lot of comments and questions on the new features post Java 8. So people, the developers, they want to use the new features, which is in 9 and beyond. But a lot of them have questions about which version to move to. Because when you talk about moving from 8 to 11, a lot of developers, they think that moving from 8 to 11 and 11 to 14 would be probably the same thing, or moving from 8 to 14. So one question is which version to move to, and the other one, which most of the developers are asking, what are the issues and what are the precautions that they should be taking?
Yeah, those are excellent questions, and they sound like a topic for another talk. Yes, so I did. Where's my link? So I've covered some specifics around the actual migration at this blog here. It's easier to do this in a blog form because I can actually talk about the tools that you can use, the warnings you might get, and I've got links to a bunch of more information. I would definitely suggest migrating to 11. It is the current long-term support release. You really, in my mind, I really think you want to take that step from 8 beyond 9 in particular, because 9 had a lot of changes. So you want to take that big step between 8 and 11 and address all of those things. A lot of these things are covered in this article here. And I think that it will be a lot easier to upgrade from 11 to 14. So I would go 11 first. Definitely, if you're in a large enterprise in particular, they're definitely not going to let you upgrade to 14 anyway. They're just going to want the long-term support release. They're probably going to want to figure out, like, who are you going to get your JDK from? Do we need to pay support costs? And so forth. So yeah, you're going to want to go to 11, and you're going to want to make sure that you've probably got that long-term support if you are in a large enterprise environment.
Absolutely, I agree. So even though this question sounds simple, there are a lot of dimensions to the answers. So, so everyone, so do read the article, because I have read that article, and I think there are a lot of pointers for you to take into consideration when you are moving beyond Java 8. So the other, so a lot of people liked records, and there were a lot of questions also. One, I would say a lot of questions were on how they could use records. Is it good to use a record as a JPA entity? Could they use record as a DTO entity as well?
Yeah, I don't know. So I haven't done any JPA for ages, so I don't know the shape of that. In terms of a DTO, I definitely think a record is the right thing to use if you are literally sending just data from one place to another. You can add behavior as well. So it's not just a data object. It's not just a simple object with, like, it's not just a Java bean with getters and setters. You could add, for example, let's see if I've got my record. So I can add stuff on here, and I can say, like, I don't know, public, do some things, do some calculation. And so you could do some simple stuff. So, let's say that's an int. 0. So yeah, so you can have logic, you can have business logic on your records as well. What I've been doing with my code, with my sample code and my own projects, I've basically started with a record first, and then sort of seeing if I need to change it into something else. Generally, particularly for domain objects like users, customers, orders, what have I got? Like moods, actually my moods are enumerations. A bunch of stuff there. Like I've just basically used records straight away, because a lot of them are just containers for data.
Absolutely. So the main purpose is to use as a wrapper for your data. Of course, if you want to add any business logic, that could be done as well. And it was great to see the benefits of modules covered in the presentation, because there are a lot of fears about the modules in Java, which was in Java 9. And as we know, it was more about for the JDK rather than for us. And having a runtime environment that could be custom made is again a great benefit. So anyone who's considering moving from beyond 8, Trisha, I think that was a great point that you covered in your presentation. The other question, there's so many of them. Just so I would also like you to share a little bit more about the preview features, because as you mentioned, a lot of features that you covered were preview features. So anything that the users need to kind of be aware about. And I know in intelliJ IDEA, they could use it without doing a lot of settings or adding any command line options, so which is great. So any other thing that they take care of?
Yeah, I mean, I think the number one thing I'd want to say is that don't use preview features in production. They will change. We've already seen this. Text blocks in particular went through a number of different, text blocks look so simple. It's just like three double quotes, that's it. But it went through a lot of different iterations. And we saw with switch expressions as well, the syntax will change. So don't use it in production, which means also, since we're on that topic, if you do end up having something like this in your pom.xml, or you'll have something similar in Gradle, you shouldn't have that in your production build. You shouldn't have it in your Gradle file or your pom.xml file for your actual production application, because then you'll be using preview features in production. I mean, you can, there's nothing wrong with them, they're not broken, but the fact is that as soon as you upgrade to the latest JDK, you will probably have to change actual syntax, which is not what we do in Java. So that's my first tip. What's my other tip? So yeah, the other thing actually is that you should be able to use, let me bring up my terminal. You should be able to use preview features from JShell. So JShell would be another good place to try preview features. I believe they're turned on by default. I have not tried this, so let's see what happens. Let's see, can we do a new record? How would we do that? Oh my goodness, now we have to see that I don't actually know how to use JShell or Java. If I'm not inside the IDE, I don't actually know how to do stuff. Is record, like, is that fine? There we go. I don't know. But yeah, you could use JShell to sort of try out these, to try out the preview features. What else is, I don't know, I really think my main thing is don't use it in production code. Do use it in experimental code, maybe even use it in test code if you want to, but yeah, don't use it in production code.
Absolutely. Use it in test code and let Oracle know what your feedback is. Because if there are any big gaps that need to be kind of taken care of, that should go to the creators. So that, yes, those are.
Thank you for mentioning that. Yes, Oracle really is very keen, and developers on OpenJDK, they really do want to hear your feedback. The reason why they changed from break to yield in switch expressions is because everyone said break is weird and I don't like it. So they are, the reason to have preview features is to ask developers, like, how does this feel for you? Does this make sense? And to hear that feedback.
Right. So there are a lot of other questions, but we are running out of time. So one last question. Since you mentioned Project Loom, a lot of developers are really excited about it. So there were a couple of questions on which version they could try out the features on. So probably we could just mention that the build is, early access is already available and people can just go and try it out. We will post the link in the chat. I'm sorry, I quickly answered it because we were running out.
No, that's fine. No, I'm glad you did, because I was like, I'm not sure I know the answer to that. Yes, you're right. The early access is available. Download it and try it.
Right. Thank you so much, Trisha. So that was an amazing presentation.